Imagine standing at the North Pole, a place of stark beauty and profound mystery. Feel the biting wind, see the endless expanse of white, and know you're at the very top of the world, surrounded by endless ice, a landscape that stretches to the horizon in every direction, a seemingly barren and desolate place. And above, the shimmering aurora borealis dances across the night sky, a celestial ballet of light and color, painting the darkness with ethereal beauty. It's a reminder that even in the most extreme environments, nature's artistry prevails. We know gravity keeps us grounded, firmly planted on the surface of our planet, preventing us from floating off into the vastness of space. It's a fundamental force that shapes our world, and magnetism guides our compasses, pointing us towards the magnetic north, a reliable guide for travelers and explorers throughout history. It's a force that helps us navigate the world. But there's another invisible force at play, a silent guardian that operates unseen, yet its influence is profound. This force is a vast, silent river of energy, constantly flowing, a dynamic and ever-present phenomenon. An electrical field, a complex web of interactions that extends far beyond what we can readily perceive. Flowing from our upper atmosphere into space, a continuous exchange between our planet and the cosmos. Born from a simple imbalance high above, in the rarefied atmosphere where the Earth meets the void. It quietly shapes Earth's destiny, influencing everything from our climate to the very habitability of our world. For centuries, it was just a theory, a whisper in the halls of science, a concept debated and pondered by researchers. A ghost in our planetary models, an elusive element that was difficult to quantify and understand fully. This field acts as a gentle push, a subtle but persistent force that influences the movement of particles, sending a steady stream of particles, a constant outflow that helps to regulate our atmosphere. From our atmosphere into the cosmos, a planetary breath released into the vast expanse of space. It's a planetary exhalation, a vital process for maintaining equilibrium within our atmosphere, crucial for maintaining the balance, the delicate equilibrium that allows life to flourish on our planet, that allows life to thrive in all its diverse and wondrous forms, from the smallest microbe to the largest whale. Only recently have we measured with sophisticated instruments and advanced technologies, and begun to understand the intricate workings of this invisible force and its impact on our planet. This subtle, persistent energy, a constant presence that shapes our world in ways we are only beginning to grasp. It's not a violent storm, a cataclysmic event that grabs our attention with its fury, but a quiet, continuous process, a steady rhythm that hums beneath the surface of our planet. Earth's electrical heartbeat, a subtle pulse that sustains the delicate balance of our atmosphere. This discovery opens a new chapter in our understanding of the complex systems that govern our planet, in understanding how our planet functions as a single interconnected entity, a delicate web of life and energy, remains a living blue oasis, a vibrant and thriving world in the vast emptiness of space, a testament to the power of balance and the beauty of life. We're all familiar with gravity, that invisible tether that keeps us grounded, Earth's anchor, firmly rooted to the surface of our planet. It's the force that dictates the orbits of celestial bodies and shapes the very structure of the cosmos. And then there's the magnetic field, an invisible shield that deflects harmful solar radiation, its shield, protecting life as we know it from the sun's potentially devastating energy. This magnetic field is what gives us the mesmerizing aurora borealis, a stunning display of nature's power. But beyond these two well-known forces, there's a third force, a more subtle yet equally important influence, the ambipolar electric field. It's a force that operates in the upper reaches of our atmosphere, playing a crucial role in regulating the flow of particles into and out of our planet. High in the ionosphere, where the atmosphere meets the vacuum of space, sunlight energizes particles, stripping electrons from atoms and creating a sea of charged particles. These light electrons, energized by the sun's radiation, try to escape, propelled by their newfound energy and the desire to break free from Earth's gravitational pull. But as they surge upwards, they leave heavier ions behind. These ions, being much more massive, are less easily accelerated and tend to linger in the ionosphere. This separation of charge, with lighter electrons moving upwards and heavier ions remaining below, creates a weak but persistent electrical imbalance. And this electrical imbalance gives rise to a planet-wide electric field. It's a subtle force, but its influence extends throughout the upper atmosphere and beyond. The electric field, in turn, exerts a force on the charged particles, dragging electrons back towards the Earth. but crucially it gives ions a crucial upward push, counteracting gravity's pull and providing them with the energy they need to overcome Earth's gravitational field. This upward push is what allows them to escape into space, slowly bleeding away Earth's atmosphere over vast stretches of time. Unlike gravity or magnetism, which primarily hold things in place or deflect them, the ambipolar field actively expels particles, acting as a kind of atmospheric regulator, controlling the rate at which our planet loses its atmosphere. It's strongest over the poles where the Earth's magnetic field lines converge and funnel charged particles towards the atmosphere. This is because, at the poles, magnetic field lines open to space, providing a direct pathway for charged particles to escape the Earth's atmosphere. This phenomenon is what creates the polar wind, a constant stream of particles flowing outwards from the Earth's polar regions. This gentle outflow, primarily composed of hydrogen, the lightest and most abundant element in the universe, and oxygen ions, heavier but still susceptible to the ambipolar field's influence, is a fundamental part of the complex interplay of forces of how Earth interacts with the Sun, shaping our planet's atmosphere and influencing its long-term evolution. Recognizing the ambipolar field as a key player in this intricate dance of forces adds new depth to our understanding of planetary processes and atmospheric dynamics. Ultimately, it helps us better understand the conditions that make a planet habitable and what factors might lead to its long-term survival. Earth isn't just held in place by gravity and shielded by its magnetic field. It's also subtly regulated by this planet-wide electrical engine, a delicate balance of charged particles and electric fields. Small forces, operating over immense scales and across vast stretches of time, can shape the fate of worlds, determining whether they remain habitable or transform into barren landscapes. Earth's atmosphere breathes by exhaling particles into space, a process called the polar wind. This isn't wind as we know it, but a steady outflow of charged ions from the upper atmosphere, especially near the poles. Sunlight in the ionosphere creates a plasma separating electrons and ions. The ambipolar field gives positive ions just enough energy to escape gravity, flowing outward along magnetic field lines. The polar wind is mainly hydrogen ions with some oxygen. This loss is slow and natural, part of Earth's self-regulation. The amount lost is tiny compared to our vast atmosphere. The polar wind connects Earth to the solar system, reminding us we're part of a larger cosmic dance. It's a story written in invisible particles, shaping the air we breathe. How does a force that lets our atmosphere escape help life? It's a paradox, but a vital one. The ambipolar field and polar wind regulate Earth's atmosphere, letting excess hydrogen escape. This slow leak prevents dangerous buildups and keeps our air balanced for life. It's planetary housekeeping, removing what's not needed, preserving what is. The field's existence depends on having an atmosphere, magnetic field, and water, the ingredients for life. Without it, Earth might be barren, like Mars. The ambipolar field is a sign of a healthy, active planet. Alongside gravity and the magnetic field, it's part of a multi-layered defense system. It doesn't shield like a wall, but fine-tunes our atmosphere for long-term stability. This quiet regulator has helped Earth remain a haven for life for billions of years. For decades, the ambipolar field was a theory never directly measured. Measuring such a faint, diffuse field required a bold mission, NASA's Endurance. Unlike satellites, Endurance was a sounding rocket launched straight through the aurora over the North Pole. In May 2022, it soared from Svalbard, Norway, aiming to measure Earth's ambipolar field directly. On board were sensitive instruments to track the energy of electrons and ions in the ionosphere. The challenge: isolate the faint signal of the ambipolar field amid the chaos of the aurora. For 15 minutes, Endurance gathered data capturing a force that shapes our world. The mission's success was a triumph of curiosity and engineering. For the first time, we had a direct measurement, a number, not just a theory. This anchors our models of Earth's atmosphere and its interaction with space. Endurance's brief journey changed our understanding of our planet forever. The Endurance mission revealed Earth's ambipolar field is just 0.6 volts, less than half an AA battery. How can such a tiny voltage push our atmosphere into space? The answer: scale. This voltage is spread over hundreds of kilometers in the upper atmosphere. The field is weak at any point, but its persistent push adds up for ions traveling upward. It's like a gentle ramp, barely noticeable, but over a long distance it gets you far. The low voltage surprised scientists, who expected more. Yet it's enough to drive the polar wind and maintain Earth's balance. This finding forces us to refine our models and appreciate the system's fine-tuning. Immense power doesn't always require brute force. Sometimes a gentle, steady push shapes a world. Science thrives on such elegant surprises. To truly appreciate why Earth's delicate balance matters so profoundly, we need to look beyond our own world. We need to consider the fates of other planets, particularly those that share a similar origin story. Let's look at Venus, often called our twin due to its similar size and initial composition. For a long time, scientists believed Venus might harbor life, much like Earth. But today, Venus is a hellish world, a stark contrast to our vibrant blue planet. Its surface is hot enough to melt lead, and its atmosphere is thick with toxic gases. Evidence suggests that Venus may once have had oceans, vast bodies of water that could have supported life. Imagine a Venus with a climate similar to Earth's, with rain, rivers, and perhaps even thriving ecosystems. However, a crucial difference between Earth and Venus lies in the presence of a strong magnetic field. Venus lacks this protective shield. Without that vital shield, Venus is directly exposed to the harsh realities of space. The solar wind, a constant stream of charged particles from the sun, slams relentlessly into Venus's atmosphere. This constant bombardment strips gases away violently, molecule by molecule, slowly eroding the planet's atmosphere. On Earth, the magnetic and ambipolar fields work in concert to protect our atmosphere. They create a controlled leak, a carefully managed release of certain gases into space. This allows hydrogen, a light element, to escape gently, preventing it from accumulating and altering our atmosphere's composition drastically. In stark contrast, on Venus, the sun's particles act as a destructive force. They blasted hydrogen away indiscriminately, preventing the formation of water molecules. This continuous loss of hydrogen had a devastating consequence, preventing water from reforming and replenishing the planet's oceans. Over vast stretches of time, Venus gradually lost its oceans, a catastrophic event that forever altered its destiny. This led to the development of a thick, toxic atmosphere, trapping heat and creating a runaway greenhouse effect. The result is a runaway greenhouse effect, where the planet's temperature soared to unbearable levels. Earth, fortunately, avoided this catastrophic fate. We were able to avoid this fate thanks to its unique and interconnected defense mechanisms. Our powerful magnetic field acts as a shield, deflecting the majority of the harmful solar wind, and the ambipolar field carefully regulates the leak of gases from our atmosphere, preventing a runaway loss of vital elements. We lose a little hydrogen, a necessary process for maintaining atmospheric equilibrium, but we manage to keep our water, the lifeblood of our planet. Two planets, so similar in their beginnings, yet one has become a cradle for life, teeming with biodiversity and breathtaking landscapes. The other has transformed into a furnace, a desolate and uninhabitable wasteland. The crucial difference between these two worlds lies in a subtle, regulated escape of atmospheric gases on Earth. This is in stark contrast to the chaotic and violent loss of atmosphere experienced by Venus. The ambipolar field, often overlooked, is a key reason why we have a home at all, a planet capable of sustaining life as we know it. Earth loses about 90 tons of atmosphere daily, mostly hydrogen via the polar wind. That's 3 kilograms per second, but compared to our oceans, it's nothing. Earth's oceans hold over 100 quadrillion tons of hydrogen. The leak is like losing a drop from a swimming pool each year. This process has gone on for billions of years and will continue long after the sun's life ends. The slow leak is part of Earth's natural equilibrium, not a threat to our water supply. The real dangers to our water come from human actions, climate change, pollution, and mismanagement. Understanding the polar wind gives us a baseline for planetary health. It reminds us of our responsibility to protect Earth from faster, human-driven changes. Measuring the ambipolar field marks a new era in understanding our planet. We're now exploring Earth from the top down, where it meets space. The field's discovery reveals hidden connections, tiny forces with huge impacts. The aurora's glow is now a sign of this invisible process at work. Science links the smallest particles to the fate of our world. The Endurance mission is just the beginning. Future missions will deepen our knowledge. We're part of Earth's story, uncovering the forces that make life possible. The adventure of discovery continues, and our awe for this planet only grows.